Assalamualaikum and very good evening. My name is Arif Mustaqim bin Mat Saleh. My ID number is TE18019. Okay, first of all, I would like to thank you to our SV and my teammate, in particular TS Dr. Nur Munira Muhammad and my teammate Yusri Ahmad and Deborah Ana Ali. Okay, so I'm going to give you a brief about our study and so on, in particular to fulfill the objective first. Okay, the title is acceptable for the first time is the installation of solar power plant based on the assessment of site selection, solar irradiance and slope analysis in Malaysia. Malaysia is in a growing period in terms of population density, but also required up with current advance in terms of population density. Okay, so because Malaysia is one of the nation that gets direct solar irradiation, solar energy is critical to safeguarding and sustaining our future ecology.
My name is Deborah Anak Aili. My ID number is TE18080. So today I will be presenting about the objective of this research, which is number one, to visualize the spatial distribution for solar panel plant located at Ampang, Kuala Lumpur, based on the topography. And number two is to identify the maximum azimuth angle and solar irradiance for solar panel at selected site. And the last one is to analyze value factor of safety FOS for the solar panel plant at the selected site using SlopeW software.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syaizat bin Ahmad Temuzi. My metric number is TE18041. I will present about our research project of methodology. So this is the studies of the installation of solar panels plant, which is divided to two of site selection, which is flat and hilly area. So after that, we will visualize spatial distribution for each criteria using ArcGIS software. And then we will determination of azimuth angle using 3D SunPath software and getting the solar irradiance using the formula. So after that, if it is the hilly area, we will generate a factor of safety using FOS. And then we will have a conclusion and also potential of market.
Okay, as a result, in regard to the hierarchy of the site selection criteria, there are three criteria. First, slope, second aspect, and third, terrain. Okay, so what's followed here is the outcome of the map created using the DEM, and this map shows the lowlands or the flat area in Ampang, Selangor. So the flat area, which is the first terrain surface that have been shown in the map, the minimum altitude is 59.05 meter and the average altitude is 65.93 meters. So the area of the study comprises natural land, trees, road, housing, water tank and other man-made structure. Human-made building range in elevation from 63 meter to 181 meter in height. Okay, this map shows the sloping region in the flat area. The topography natural surface is tapered between 5 degree to 10 degree in slope. So by referring the method of expressing slope, this area can be stated or can be chosen as a flat area because the percent of the taper is 0.5% until 1% only. Next, okay, this aspect condition that may be found in the flat land or the flat area is shown in this map. So consequently, they are consist of 9 facing downslope direction, including the flat area. So the aspect map show the highest percentage of downslope direction is flat area, which is 13.9%. Okay, so on this section, I will go through the hilly area of the research that we conducted. Okay, so now, the study area for the installation of the potential solar panel is located in the hilly area in Ampang, Selangor. So the size of the study area is approximately 100 square feet. The maximum altitude is 2295 meter and the average altitude is 84 meter. Okay, here the slope condition of the study area in the hilly area in Ampang, Selangor. The slope gradient of the study area is divided into 6 categories. Each category increase 5 to 45 degree. So the slope progressively decrease from the east to the west. South facing slope obtain higher solar radiation compared to the north facing slope. So the slope with a gradient 10 to 30 degree will gain more than enough solar radiation So the overall insolation value is around 4719 kilowatt per meter square. Okay, this map shown the aspect condition of the hilly area in Ampang, Selangor. So the aspect facing from average 135 degree to 315 degree would be holding the most value of insolation. Okay, this elevation of the study area that may be found show on this map. So the maximum elevation is 2295 meter, average elevation is 84 meter, the higher elevation area on the observed in the northeast, but the lower elevation area are in the southwest. So in the southeast, the ideal elevation for placing solar panel has been determined.
Okay, this is to answer the second objective of this project, which is identification of azimuth angle and to get the solar irradiance using the formula. Okay, first is azimuth angle is the angle of PV solar panel direct from the sun, and the solar irradiance is the radiance from sun to PV solar panel. We need to compare that to get the best of solar irradiance, best of sight, we need to have the highest value of solar irradiance. Okay, this is 3D SunPath software. We can use this to get the azimuth angle. Okay, first is we enter the latitude and longitude for each area. For this case, this is flat area. And then we enter the date and time. We choose time on 12 o'clock because of this is the solar noon of the day. And then in the solar information part, we can get the azimuth angle, which is on the red line. Okay, after that, this is identification of azimuth angle for hilly area, which is repeat the same step, but the difference is we enter the different latitude and longitude. Beam, diffuse, reflected, and global solar irradiance on three angles of PV module for hilly and flat area. Okay, to get the solar irradiance, in the formula, we have to include the solar beam, diffuse, and reflected for both hilly and flat area. Okay, we can see that the solar irradiance for hilly and flat area have difference between the range. For hilly area, which is the range on scale to 1200 kilowatt meter per square until 1400 compared to flat area, which is more lesser, which is range of 850 kilowatt meter per square until 950 kilowatt meter per square. For the discussion, we can see that in Ampang of selected area, the solar irradiation has the potential to be used for PV energy generation for both of sites. We can see that hilly area have the highest value of solar irradiance compared to flat area, which is solar in hilly area have 1333.56 kilowatt meter per square, and compared to flat area, which is 942.67. According to the research that have been made, the best PV energy generation site, which is on scale to 1200 kilowatt meter per square until 1300 kilowatt meter per square. So in this case, the hilly area have the best potential, which is included in the best site PV energy generation. That's all from me. Thank you.
Now, before we proceed with the slope analysis result, here is some information that we extracted from the site mapping of hilly area, which is slope angle data. And from the azimuth angle, determine that hilly area have the highest value of solar irradiance. And based on the research conducted by Kamo and Lim in 2003, determined that the type of soil at the hilly area selected is unsaturated sandy sill. Therefore, I decided to use the method of Spencer, Bishop, and Janbu to do the slope analysis. However, the main method is Spencer. Bishop and Janbu method is used to see the consistency of the FOS value. Now, this is the factor of safety value. For the Spencer method, we obtain 1.005 and also consistent FOS value for Bishop method, which is also 1.005. However, for Jambu method, we obtain 0.914. Now, based on the Schuppner 2010, factor of safety, which is less than 1.0, the slope is categorized as unstable. However, for factor of safety which is bigger than 1.0 is sufficient to classify a slope as a stable. Now, here is why. For the jumbo method, we obtain 0.914. For jumbo method, only force resisting and force activating that reacted on the slope model that caused instability due to the nature of the analysis method itself. And for Spencer, both moment and force of resisting and activating at the same time reacted to the slope model, which provided more accurate result and much stable slope. However, for Bishop method, only moment of resisting and activating reacting on the slope. Therefore, the nature of Bishop itself employ a trial and error method to determine the element of safety, and therefore this method obtain corresponding value with the Spencer method analysis that has been conducted. Now we will proceed with the conclusion. First one is the issue of solar potential is one of the initial consideration for soil selection for a solar power plant. In this research, where the plant will be installed, the more solar radiation implies the more energy will be generated, implying that it is a hilly terrain that has got high irradiation capable is converting solar energy to electricity consistently. And number two is hilly area has been selected because of having the highest value of solar irradiance rather than flat area. And the last one is to determine that the Spencer approach is reliable for determining the factor of safety, FOS of 10, that is 1.005, which is adequate to support the argument that the slope is stable and suitable for the construction of solar power plant on the hilly area. Now, this is the potential market of this research study. Number one is the Tenaga Nasional, and number two is Sarawak Energy. Now, that's all from our group. Thank you.